Hello, ladies and gentlemen, and welcome back to question number 23 on the 2002 Cayley competition. In trapezoid ABCD, AD is parallel to BC. Also, BD is perpendicular to DC. The point F is chosen on the line BD so that AF is perpendicular to BD. So AFD is a perpendicular, so we got a right angle here. That makes that a right angle, and those two are going to have to be right angles. So we got a whole bunch of right angles here. And actually, I think that shows that AF and DC, so we got that Z pattern, AF and DC are going to have to be parallel. So I think AEDC is going to be a parallelogram. But let's finish reading. So AF is perpendicular to BD. AF is extended to meet BC at point E. If AB is equal to 41, and AD is equal to 50, and BF is equal to 9, what is the area of quadrilateral FECD? Alright, so FECD. So, I'm noticing, first let's redraw the picture, but I'll explain as I talk what I'm noticing. And they also, very odd, they left off their, the lengths. They usually include the lengths when they do these things. They include the lengths in their pictures. Not that big a deal. So, as I say, I'm pretty sure we have a parallelogram here. With that F. Here's E, C, D, A, B. We're told AB is 41. So we got a 50 here. What else were we told? BF is 9. Oh, I have E and F misplaced. This is F up here, and this is E down here. So we got 9 here, and we have right angle triangles all through here. They only showed us one in the picture, but we can prove that the rest all exist. So like I say, I think because we have that familiar Z pattern here, that these guys are going to be parallel. I don't know if that's going to be particularly useful, but we've got that going on. So we want this quadrilateral in here. So one thing we could note is we could take it out and rotate it ever so slightly and get F here, and E here, and C here, and D here. And we've got nice little legs here. Drop a perpendicular down here. Suddenly we've got it as a rectangle and a triangle. So that's one way to look at it. Another way, and this is the way I think I'm going to do because I think this will probably work out better, is we can view it as BDC, this triangle, chopped off this triangle right here. This BFE. And you'll notice that these triangles are going to be similar, and we already have a length of one of the sides of the smaller one. So I think due to that similarity of those triangles, I think this is the way that we're going to go. This way is probably pretty good as well. We still need to figure out a bunch of lengths to do either of these methods. Since we got a parallelogram here, AE will be the same as DC, and that gives us the height of this weird little quadrilateral. I guess we could also view it as a trapezoid. Yeah, lots of different ways to do this. A trapezoid here. Okay, but let's get some work done. So by Pythagoras, I've got this 41, this 9, and this right angle. AF is going to be square root of 41 squared minus 9 squared, and I'm pretty sure that that's just going to be 40. But let's double check it on a calculator. 41 squared is 1681 minus 9 squared, which is 81. 1600, and the square root of that is 40. So we're right. Okay, so we've got a 40 here. And now, well, we got another right angle triangle, AFD, hypotenuse 50, this length 40. We're going to have a 3, 4, 5 triangle, which is one of the more common Pythagorean triangles here. So once again by Pythagoras. We're going to have FD, the square root of 50 squared minus 40 squared, and if you get your calculator out, you can check that that's 30. Okay. So, however we're doing this, if we're doing one of these other two methods, if we're looking at it as a trapezoid, we now know the height is going to be 30. Or if we're looking at it as a rectangle plus a right angle triangle, we've got a side length of 30 here. But I'm going to go with this similar triangles method here. So I got a 30 here. So the area is triangle BDC minus triangle BFE. Okay. So we got this guy here. I'm just looking at other angles because there might be other triangles that we can use. That's 90 minus dot. We have, this guy's going to have to be 90 plus dot, I think. Yeah. What else have we got? Oh, well, then this has to be dot up here. So that makes this 90 minus dot. Alright. Yeah. Pretty sure we're all set here. Yeah, so we can work out this angle up here. So as I already remarked, that's AE, since AE is parallel to DC, AECD is a parallelogram. So angle DAF is the same as angle DCB. And so we have a whole bunch of similar triangles. So triangle ADF is similar, oops, wrong symbol. Similar to CDB, which is similar to triangle EFB. And let's just make sure we got the order right. That's the 90 minus dot, that's the 90 minus dot. So A is first, then C is first, then E is first. A is first, C is first, then E is first. Okay, we got them all right. Okay. So, because they're all similar, that means that there is a common ratio with their side lengths. And so from there, what can we do? So AD over, if you write them out the right way, the order, the ratios are going to become apparent. AD over CD is going to be the same as DF over DB. And that's going to be the same as FA over BC. Okay, so that's one of the results that we have. We also have pairing the first triangle up with the last one, AD over EF, is going to be the same as DF, we'll have FA over BE, and this one will be DF over FB. Okay, so I think we can fill out some of these. We can definitely fill out all the lengths in ADF. And then we've got a 9 here, and a BD is 30 plus 9, so that's 39. Okay. So AD is 50. DF is 30. And we got 40. DB is 39. CD and BC. Okay. Well, 30 over 39, that's a definite number that we can know, and that means we can work out CD and BC. So CD is going to be 50 times 39 over 30, just cross multiplying here. And that's going to be 39 times 5 divided by 3. We'll get 65 here. And likewise, BC, if we cross multiply, we'll get 50 over 40 times 39. Or sorry, 40 over 30. Silly me. Over 30, so that'll be, the 10s will cancel out. We'll have 4 over 3, but 39 has a 3 in it, so it'll be 4 times 13, so that'll be 52. Okay. So going back to our picture, we can fill it out a little bit more. CD is 65. And, oh sorry, BC is 65. And CD is 52. I feel like I have those screwed up. I feel like I have the order wrong. Did I not match these up right? FD and BD should be right, and then BC should match up with AD. Why don't I have BC under AD? That's very confusing. So I wrote my triangles out wrong. I need to have BC over here, and then this one's got to be CD. Sorry about this. Because BC has to be the longer one. Okay, so now rewriting this one to make sure it's in the right order. B has got to go here. F is where the right angle is, and that was where D is. We've got E here. Okay, so now we got to correct these ones. EB, BF, and FE. Okay, so hopefully that's right. So we were able to work out all these other lengths. Now let's work out, we know AD is 50. We have 30 and 40. And we know that BF is 9. So that means we can work out FE and EB. So EB will be 50 over 30 times 9. And that'll be 15. And FE, once again cross multiplying, we'll get 40 over 30 times 9. The 10s will cancel out. We'll have 4/3 times 9. 9 has a 3 in it. So it'll be 4 times 3, which is 12. And we can add those to it. So EB was 15, and we've got 12 here. So we actually have just about all the information we're going to need with no matter what method we use. I want to use the BDC minus BFE method. $12, 9, and we have 39 and 52. So 1/2 base times height minus 1/2 base times height. And we just grab our calculator. 52 times 39 divided by 2 is 1014, and then 12 times 9 divided by 2 is 54. And when we work all that out, we should get, I think, 960, but let's just double check it. Yep, 960. And that's the area that we were asked to compute. But as I say, there's probably a couple different ways. You can do it as a trapezoid or just a quadrilateral broken up into a right angle triangle and a rectangle. But either way, you should get C, 960 for that area. All right. And we'll flip to a nice fresh page in anticipation of our next question. And that's going to be question number 24, which we'll deal with in the next video. So thank you guys for watching, and I'll see you next time.